All right, thanks for having me. It's great to be back here again. A little bit about myself for those who don't know. A lot of people know me from TV, and I always like to tell people I'm a meteorologist that just happens to work on TV. I really consider myself more a scientist. And growing up in Ohio, I fell in love with weather when I was 6 years old. I was fascinated with bad weather, and my parents thought I was crazy. We had a big blizzard that snowed in our front door. I had to climb out the window with my dad to dig out the front door, and I thought it was the best thing ever. So I wanted to study the atmosphere and the science of weather. I never wanted to be on TV because when I grew up, most people on TV were full of it. They weren't real meteorologists, and that's where a lot of some of the issues I'm still dealing with today about people not understanding the accuracy of what we do or understanding that we can get it right more often than not is you went through a whole generation of people that grew up with entertainers giving you the weather. And they didn't know what they were talking about. Nowadays, you're lucky. You have meteorologists that work on TV, degree meteorologists. My degree is in atmospheric science from the Ohio State University. So I didn't get a journalism or communication degree. My degree is in science. I just happened to stumble into TV, which leads me into my talk today, which has kind of opened a whole new door to me about bringing the technology and science of weather to people. And this is really kind of the new frontier of where our science is going. So what's the hardest part about forecasting the weather? I ask this to a lot of people all the time, and the first thing they say is probably getting it right. And I will tell you, it's not. Because we actually have almost solved that problem to the highest level I think is possible. The biggest issue we're having now is communicating the forecast. And what I mean by that is we can get the forecast correct, but a lot of people aren't getting the information in a timely manner or in a way they understand. And I'll give you some examples. Earlier in March, we had a well-forecasted severe weather outbreak. 5 days ahead of time, we knew a high risk was going to happen in Alabama. 3 days ahead of time, we knew it was going to be in southern Alabama. 2 days ahead of time, we actually down to counties. And the day ahead of time, 3 to 4 hours, we knew there would be large tornadoes in Lee County, Alabama. Yet 23 people still died. That's frustrating to me, understanding that we knew that this was going to happen and people still died. And it's been crazy. As great as forecasting and communication has gotten, there's weather data everywhere. You can get weather information anywhere. People are still being caught off guard by weather. How is that even possible? How do people not get out of the way of Hurricane Michael last year in Florida? It's not like hurricanes sneak up on you. It's not the 1900s when people in Galveston were on vacation at the beach and saw the waves coming up and go, oh, the waves are kind of high today. They didn't realize there's a Category 5 hurricane offshore that's going to slam into Galveston Island. I mean, we live in a time where stuff doesn't sneak up on us. Hurricanes don't surprise us. Tornadoes don't surprise us. And I say that from a meteorological standpoint. But from a public standpoint, things still surprise people because people are either out of touch or, in my opinion, they don't really understand and they haven't grasped the information. So technology has made us better. From just the science point, I'll talk about just the science of meteorology. Modeling has been huge. Numerical guidance, we call it. You guys have probably all heard of modeling, right? It's great. Modeling is now in the vernacular of most of the public. They hear about the American model, the European model, all these different models. But the problem is, just like probability of precipitation, the chance of rain, people don't fully understand what they're hearing. A model is not a forecast. It's a tool. It's like having a great new shovel or a great new saw or a great new nailer. It's not going to build the house for you. All right? You still need somebody to use that information to build the forecast. And what happens even in my profession, young meteorologists are over-reliant on the model data. And it actually makes the forecast harder to understand and actually makes it less accurate. But any model isn't going to be good unless you have good data, right? You guys know this better than anybody. If you have a great model, it's a garbage in, garbage out kind of thing, right? So we've done better with data collection. I'll talk about that. To me, this is the one thing. Visualizations, graphics. How are we visualizing the data that we're giving to people? To me, that's something we could do a much better job of, and that's where technology has really helped out. When I first started in this career, I got into TV right when I graduated in 1997. We had two-dimensional graphics. All right, the atmosphere is not a two-dimensional thing. It's four-dimensional, actually, if you think about it. But it's a 3D. It goes up and down. We have stuff above our head that people couldn't visualize because you had a 2D map. When I forecast snow here, which is one of the most difficult things to forecast, people are like, oh, how is it so hard to forecast snow? Well, it's not the temperature at the ground. It's a temperature at 5,000 feet, at 10,000 feet, at 15,000 feet. And it's not just a degree. People don't realize the difference between freezing and not freezing is 32.0 and 32.1. It's not 32 and 33. It's a tenth of a degree difference. at a certain altitude can change whether you see snow, sleet, or freezing rain. So these are really hard things to visualize, and now that we have 3D graphics, the ability to show this, it makes it a little bit easier to understand. These have all increased our accuracy a lot. Let's talk about modeling. I love that image right there. That looks like a satellite image. That's actually a NOAA model simulating the atmosphere. I mean, we have modeling now that makes images that look like a picture. I'm just going to have this play in the background. Oh, there's audio too. The music's just for dramatic effect. But this was a model of a supercell thunderstorm, and you could see all the complex things going on in this thunderstorm. And this wasn't possible 10, 15 years ago. Now the data we're getting, and people wonder why, you know, my mom wondered why I storm chased, okay? And people still ask, like, why are there storm chasers? It's so that we can collect data like this in the field and bring it into a model. People may not realize that we have Doppler radar on wheels that travel and park around a supercell thunderstorm. We triangulate 3 radars that shoot radar beams into the storm and collect data. So if you guys ever seen the movie Twister, okay, it's horribly inaccurate, but it's still a cult favorite of mine. But you guys remember Dorothy, right? They were going to throw these sensors. You don't have to do that. Those particles are already in the atmosphere. We just bounce a radar beam off of it and get the information from debris. A 2x4 or a shingle flying around with a Doppler radar beam bounce off it, we can get direction and wind speed based off the Doppler radar. So what we've done is we can simulate the particles within a thunderstorm, and in this case, how a tornado forms. And you can see the complex nature of what's going on in these tornadic storms. So it's visually amazing, right? And it's like, to me, I look at this and I'm like, we call this weather porn in my business, because we sit there and look at this and it's just like, it's just stunning to see how it develops. And this is why I loved chasing tornadoes, because everything you learned in a textbook was in a textbook. You go out and see this thing in real life, it's amazing. So the second part of modeling is the data collection, right? How many of you guys know we fly Global Hawks into hurricanes? Okay, we fly, now this is, you know, from early Middle Eastern wars. We had drone technology that was, you know, for just death and destruction, but now we're using the Global Hawk to fly 24-hour missions around hurricanes, collecting data 24 hours a day. These are amazing, flying into hurricanes. And eventually these are going to fly around the US and collect data in real time. Because one of the things we still do are launch weather balloons twice a day all over the world. You may not know that, but the weather balloon gives us great data from the ground up to the top of the atmosphere. But we're starting to replace that data with either balloons that'll be permanently floating around, some kind of blimp type device, or we'll use drones that can stay airborne for 2 or 3 days at a time. One of the coolest things I've gotten to do in my career is go see the launch of GO-16 down at Kennedy Space Center. To be able to walk down there and be up next to the rocket before it took off was amazing. GO-16 and GO-17 are the latest technology in satellites. Satellites are really helping to collect data that we couldn't get otherwise. So weather balloons are only launched at certain locations around the world. Greensboro launches one and Atlanta launches one. That's a pretty big distance. There's a lot of data we're missing in between. And those are launched at the same time all over the world. But what the satellites are able to do for us now, and this is Hurricane Michael from last year, just to show you the power of the GO-16 satellite. This is a half-kilometer resolution every 30 seconds, okay? To be able to see inside the eye and see mesovortices, and at one point, you swear you see the Hurricane Hunter aircraft flying through there. I mean, there's times you could see it. To get this kind of resolution is just amazing to me. But the thing that the satellite does that beyond these visuals that are amazing is that it actually takes soundings of the atmosphere all the time. It bounces a radar beam off the ground back up to space, and we get temperature profiles of the atmosphere. So things that would have taken a weather balloon are now being done by the satellite. And the cool thing about the satellite, it can measure every square inch of the area it's looking at. We don't have to wait for Greensboro or Atlanta's, you know, weather balloon. I can get a sounding for Charlotte based off the satellite. Now it has to be clear skies. That's the only bad thing, because the laser is going to bounce off the top of the cloud and not make it to the ground. So clear skies are what you need. But you get these amazing images that allow us to see things that, you know, we couldn't see 10, 15 years ago. And if we did see them, it was like looking at an old analog 4x3 TV, and now it's like 4K high resolution data. And this helps supplement some of our radar data. You know, radar data, a lot of people have radar on their phone. I love it. People tell me, Oh, it looks like the storm went around my house or whatever. Radar has huge limitations. It's ground-based. It's like a cell tower. The farther away you are from the radar site, the worse the data is. It's horrible. In some places, there's giant voids where you get no data at all. Now, on your apps and on your phones, it'll kind of interpolate or smooth that out, but that's not really real data. What the satellite does is allow us to fill those gaps. So now I can get, I just told you 0.5 kilometer, 30-second resolution. I can see a cumulus cloud turn into a thunderstorm in real time on a satellite image. It's amazing, before it even produces a drop of rain. So this data has been invaluable. So the data is amazing, right? And it's gotten us a lot better. I mean, the trend in hurricane forecasting, just as an example, the average errors have gone down to less than 50 miles. I mean, it's pretty amazing. And even at day 5, which is 120 hours, the errors are only around 100 to 150 miles. So it's amazing. The accuracy is improving dramatically. But we're still dealing with this, right? I don't know how many times a day I hear this joke. I'm surprised I didn't hear it in the elevator on the way up. I wish I had a job. I can be wrong. I heard it yesterday at the Microsoft store. Guy comes up to me. He was a real nice guy, but he told me this joke, and I was like, oh, come on, are you kidding me? Of all places, the Microsoft store, I'm going to hear this. So, I wish I had a job where I could be wrong, and the percentage always changes based on how bad they think you are, right? 80%, 90%, 70%, 50%, whatever it is, and keep my job. The thing is, that still perpetuates our society for some weird reason. And why, you're probably saying, oh, Brad, get over it, But I think it has problems with communication because people perceive this erroneous thing. So they don't want to believe the information you're giving them because they say, oh, they're wrong all the time. So they're less inclined to believe severe weather information. Or my favorite is, Lewis Black said, what meteorologist is in English? It means liar, And I always said, well, we're lying. Come on, we're predicting the future here, Or my favorite comment, some of these comics about, he's watching his favorite comedy as God looks down at the 5-day forecast. Or one of my other favorites, there's no bad weather, there's just bad weather forecasts. I get that a lot. People blame me for the weather all the time, and I'm like, my running joke for them is I work in sales, not production. Okay? I don't produce the weather. I'm here to tell you what's going to happen. I'm not responsible. So when the weather's nice, I always tell people, don't thank me for it, because I don't want to take the blame for the bad weather. And then one of my other favorites is, as a meteorologist or reporter, I always feel guilty when it rains. I don't know how many times I get the wedding question. Oh my gosh. I'm getting married on Saturday at 5 o'clock. What's the weather look like? And I'm like, bad? I mean, I'm like, and then they tell me we didn't get a tent. And I'll be like, oh. I'm like, how do you plan anything outdoors without a backup plan? It's just, so it's like now you're trying to say, is there a 30-minute window I can get married outside? It's like, so I get guilt by that. And that's just a simple thing. It has nothing to do with bad weather. So how accurate are we? Now, depending on the methodology that you use, most sources of weather forecasts, believe it or not, for the one-day forecast are 80 to 90% accurate. That means about 80 to 90% of the time. Even your apps are going to be right about 80% of the time, okay? Now, my station, I'm one of those people, I'm really geeky, so I keep spreadsheets on our 5-day forecast. And it's more to keep me in check, but it's also to identify any biases I have. Like if I'm too cold or too wet or too warm, I'm like, why am I doing that? So I will adjust my forecasting. But my station found out I was doing this, like, hey, let's start pushing this stuff out and tell people. And I love that. It's like more transparent. And people always think I'm full of crap, like, oh, no way you're right, that wrong. But when I'm wrong, I blow it. Like, people don't understand that even as accurate as we are, that means 22 days a year I'm going to completely blow it. So I have to forecast 365 days a year. So if I'm right over 90% of the time, that's still close to a month where I'm going to get it wrong. So as accurate as we are, we're still going to screw it up. So why do people have this perception of us being wrong? Part of it, I think, is apps. And I'm going to tell you why. I was talking about this earlier. One of my biggest pet peeves, I read a lot of tech blogs like you guys probably do. Every review of a weather app always includes best visuals, most comprehensive data, best integration of storm data, simplistic, design, entertaining. I never see one that says anything about accuracy. Like, why in the world would you review an app that is supposed to give you a forecast and never talk about the accuracy? Like it's like having Google Maps and saying, this is a great interface. It doesn't ever get me where I want to go, but man, is it amazing, okay? The point of that app is to get you somewhere, okay? But nobody ever takes the time. And I think it is because people just accept, oh, it's always wrong, right? It's a whole joke, right? You're wrong 80% of the time. And what happens with the apps? When the apps screw up, the apps don't get blamed. I get blamed. It's not even my forecast. And we have this other thing that we joke around in the office is, I hear this a lot when I'm like eavesdropping at people. Well, yeah, I heard they said it's gonna rain this weekend. And I'm like, who is they? Like, they is this mythical group of people that forecast the weather and put it on apps and everything, and they get blamed for it, and it's not a person or somebody. Everybody's different. We're a lot like doctors and mechanics. We all don't have the same forecast because we all have different skill sets and different abilities, okay? There's nothing wrong with shopping the weather, right? You're gonna shop around for a good doctor or a good mechanic. You need to do the same thing with your weather. Don't accept the fact that you have a default app on your phone, and I'm just gonna use that, because it's not probably the most accurate app. And here's the thing about apps. I'm going to be totally honest about them. Here's the accuracy for Charlotte. Great site, Forecast Advisor, looks at the APIs from most of these big app providers. Now they have to have an API to look at, so some apps are online. You may not see them. There's 10,000 apps in the iOS App Store, by the way. 10,000. Do you think all of them are the same? So for the last month in Charlotte, the Weather Channel app has actually been correct, and this is a 24-hour forecast, so 1 day into the future. So if I'm looking at tomorrow's forecast, 79.66% of the time. And for the last year, it was 80.1%, okay? Now look at the top three. The Weather Underground, which is one of my favorites just because you can put your backyard weather station on there and look at it. AccuWeather, they're all pretty close, right? My favorite is Persistence. That's if you just take the same forecast and play it out in the future. That's like extrapolation. If you ever watched a hurricane forecast, we have all the spaghetti plots. There's always one called extrapolation. It's just taking the forward motion of the storm continuously into the future. And it's always some weird line. And people always like, let's look at that one. And they think it's a model. It's not. It's just persistence. The digital weather forecast from the Weather Service, that's kind of scary. That's that low. That's the government forecast. And that's their automated forecast. There's no human interaction, but they put out a digital forecast, which is free. And if you ever want to build an app with an API, that's the easiest, freest one to grab because the government puts it out there and it's just sitting there. But it's called the Digital Forecast Database. And you can but it's kind of scary. Dark Sky, which everybody loved, doesn't rate very high, but it has great visuals, okay? I remember when that app first came online, the people that developed it, there wasn't a single meteorologist in that development team. And they realized really quick, this is hard to forecast the weather. It's not as easy as it looks. So now they have hired a ton of meteorologists. They've improved the quality of that app tremendously. But they promised a lot of things that we're already doing, like short-range modeling of thunderstorms, tell you how far this rain is going to get, when's it going to be at your house. We already did that. They could have went to the government and got the high-resolution rapid refresh model, which already does that for you. You don't need to create your own. But just to show you, I still have a job, because that's my accuracy in the last month, and that was my accuracy last year, okay? Now, I'm not tooting my own horn. The reason I'm more accurate, I'm not automated. I can make adjustments, okay? All those APIs, they gotta wait 6 or 12 hours for new data to come in. So if something starts trending the wrong way, I can go in and say, uh-oh, change the forecast tomorrow. I see it's gonna get warmer or colder. Or today, let's say, for instance, like a lot of times just simple temperature forecasts. If I see a persistent pattern in today it got to 82 and that pattern's not changing tomorrow, I might up my high temperature a couple more degrees because nothing's gonna change. It's actually gonna be a little bit warmer. Whereas the API might have to wait for a new model run to update that. So it runs into a lot of issues. That's automation. That's, technology's great. The great thing about me is I can take automation and human information, put it together and make a better forecast. We're still at the point where humans and technology together make a better forecast than just the technology. But that's just from a forecast standpoint. Here's long range, so anybody who likes to look at the 10 to 15 day forecast, don't. Just like anything, the accuracy in the long range gets a lot worse. And the way I like to explain this is, if a front slows down 5 miles per hour, that's not gonna change the arrival of the rain tomorrow by a whole lot. But multiply that 5 mile per hour change times 10 days, now you're talking days difference in the rain. So just subtle changes multiplied by long time frames. But I will tell you, that the 5-day forecast 10 years ago is, as accurate as the 3-day forecast. The 7-day forecast is now as accurate as the 10-day forecast. And in probably the next 6 years, the 10-day forecast will be as accurate as our 7-day forecast. And it's getting better, it is. But we got to stop being modelologists. This is, I teach at UNC Charlotte twice a week, and this is one of the things I see with younger meteorologists. They've grown up with models. It's great. I can look at any model, give me snowfall forecast, tornado probability. They lost the craftsmanship or art of forecasting the weather. So they've let the numerical guidance kind of take over the forecast, and it's a tool. And what happens here is, why is this a problem? Even though the guidance is getting much better, and you can probably rely on it more than I could when I was starting in my career, the problem is you can have this happen. If you guys have seen these stories, somebody listens to their GPS and they turn into a lake, or they drive down a fire road and get lost because the GPS told them to. Sometimes you got to just look out the window, all right? If the thing says turn left and there's a wall there, don't turn left. And so what happens is, we've seen a lot of people bust forecasts because, the European model said this was going to happen, and I wanted to believe it. Around here, snow forecast, like I said, is difficult. What we have here is a lot of snow enthusiasts, I like to call them. People that like to wish cast. So they look for the highest snowfall total in the model, and it goes out on social media, and it spreads like wildfire, and then we actually get 1 inch, and everyone blames me because they saw that huge total all over social media, and I'm like, that wasn't our forecast. There's a human element to this that's not only in the forecast part, but it's the understanding of this information. And this is where I think I can fix this with technology. One of the things that we do that I think would help is called ensemble forecasting. Instead of giving a deterministic forecast, like this is exactly what's going to happen, let's give you a range of possibilities, because that's what the guidance does. We do this with hurricane forecasting, and people get it. Like, you see the spaghetti plot, right? All those lines. You know it's a spread, but you can see where they're clustered in the middle, the mean, right? People kind of get that. People aren't as bad at math as we think. They understand probabilities to a certain extent. They play the lottery. They get that there's a chance. It's not real high, but they do it for the chance. But in hurricane forecasting, we have these great plume diagrams we can show where here's the threat region, but here's where it's highest, right? Like I always like to tell people, my job isn't to forecast what could happen, it's to forecast what's most likely to happen. Now, when I talk to emergency managers, I have to tell them what could happen because they got to plan for the worst. But for most people, the public, they got to know what's likely to happen. Like, could we get a foot of snow? Sure, but we could also get hit by a meteor tomorrow, okay? But this is what's most likely going to happen. Could you win the lottery? Yes, but you better start saving for retirement another way, okay? So there's a lot of these, could this happen? Anything literally could happen statistically. That's why you'll never see me, rarely, long range put a 0 or 100% chance of rain. That's too deterministic. It's always between 1 and 99%. That's the reality of forecasting. So these ensemble graphs are great. So for this one right here, this is actually snowfall. We call them plume diagrams. So you can see all the runs of the model, but the black line is the mean. Now this is where the human comes in. If you were to automate this, you guys have this big outlier. I could remove that outlier because it's dragging the mean way up there, right? So that's what I do as a forecaster on a daily basis. I say, I take out some of these extremes and I put the mean in there. And I also like confidence. I mean, the guidance doesn't really tell you a confidence level, but a forecaster has a confidence level. So we use some diagrams like this sometimes to tell you, here's what we really are confident is going to happen, here's what we're not so confident is going to happen. That's where the human element is. People get that. Like, what is your gut feeling? I hear that a lot. Not that it's a guess, but it's like, hey, I have a high confidence that we're going to get a ton of rain. I'm not super confident there's going to be a lot of wind. That's the type of stuff as a human. But the problem is the models don't really do that, and the apps don't convey this at all. So there's got to be a way to do a better job of this. So one of the things we do, we're pretty transparent. I like to show people when I get it right, but I also show people when I get it wrong. It's just as important. So we do accuracy streaks, and there's a look at my little spreadsheet that I use to keep track of my cold and warm bias. And the great thing about meteorology is I think we're the most self-reflective people there is. Like, people think we get it wrong, but like we get more mad when we bust the forecast than anybody. And if we don't look back and figure out why we got it wrong, then what's the point? I tell all the young students, I say, there's nothing wrong with blowing a forecast. What's wrong is not learning from that blown forecast, okay? I built my whole career on busted forecasts, I tell them. I say, early in my career, I missed forecasts all the time, but I learned from every bad forecast to make the next one better. It's a good lesson in life. And too often, we don't look back at the mistakes we make to figure out how we can't not make those mistakes again. So the other thing we need to start doing, and this is where the crux of my conversation is kind of leading to, is how do we take all this science and technology and get it to people in a way they understand? What's taken over my field is something called social science. We now understand that the forecast isn't accurate unless people understand it and they act on it. So we can sit there and pat ourselves on the back and go, Brad, great job, you got that tornado warning correctly, but nobody heard it or nobody listened to it. To me, that's still a wrong forecast. And that's not about the meteorology or the science, that's about the social science. Like, how are we communicating this information? So one of the things that we found doing research is we go out and talk to people after big storm events. And we ask them, how did you get a warning? Why didn't you leave? And they tell us stuff. They like hearing stuff from other people. They don't like automated messages when it comes to severe weather in particular. They like hearing. It's like, I made this analogy with somebody at work. I said, imagine if your doctor sent you a voicemail or an automated message that says, hey, your test results are back. You have cancer. You would hate that, right? But we're doing that with weather. We're doing that with a tornado warning to your house. No, there needs to be a person attached to that has empathy that can show you that something's going to happen. Technology can't convey these threats or uncertainty very well, if at all. People like to confirm threats. So even if they know something's going to happen, this happens a lot with tornadoes. This is why everyone goes outside and looks. Because they have to confirm that the tornado's coming. So technology can help us out. Pictures and videos, social media is helping me out tremendously. If I can show someone a picture of the tornado one county away, people in the next county, they get to the basement because they actually see it. Instead of having to go outside or call their neighbor and say, hey, Judith, you see that tornado? No, they see the picture on Facebook, Twitter, Instagram, boom, they're in the basement. So social media has been a huge help in that aspect because I can get the pictures and video, turn it around and show people. People aren't very weather and news savvy, in case you haven't figured that out. I'm amazed at people that go through life and have no idea what the weather's going to be today. And they wonder why they get caught without an umbrella and why I always have one with me. Because I could never be caught outside with an umbrella. But technology can help us get there quickly. So this was a study after the Lee County tornado, which I talked about at the beginning. So back in March, horrible thing, 23 people died in a tornado. One of the things they found in the early research looking at the people, people know that they're in a risk area, but they think it's not going to hit their house. This happened with Florence last year. Oh, we know Florence is coming, it's not going to happen here. We call it optimism bias. Happens somewhere else. It's like every soundbite for every crime. We go to the neighbor, seemed like a nice guy, he seemed like a normal person. We get that all the time. No one ever sees it, right, until after. So they need to visually confirm it. We just talked about that. And this is a big problem. Your level of preparedness is only as good as your memory of the last disaster. If it hasn't happened in a while, people don't take it. This happened in New Orleans pre-Katrina. I lived here 30 years, and we've had 4 hurricanes when nothing's ever happened. I'm not leaving. Now you go down there, every hurricane, boom, people are gone. So sometimes it takes recent events. People have a bias where it doesn't happen to them recently, it's not going to happen. Folk science, I run into this still. Folk science is weather myths. So in Mississippi, there was this town where they were convinced the river stopped tornadoes. And so they would send the sheriff down to the river to see if it was going to cross the river, and if it did, then they would warn everybody. Here I get to be all the time, people are like, oh, the mountains block stuff. Or, thunder in the winter means it's going to snow in 10 days. So naturally, I look at the data. Sorry, there's no support for that. It's a random chance. Now, some of this folk science is based on some things that are kind of true, like big cold fronts in the winter typically mean a pattern change. But there's no science to it. It's just folk science. People here think buildings block things, lakes, mountains. Yeah, they have big impacts on our weather. Interstate 85, that's the rain-snow line, Never crosses the interstate. Mother Nature, this huge 60,000-foot storm, doesn't know the interstate's there. It's like a blip in the road, And so right now, this part of our science, we're kind of in the diagnosis phase. If you were related to medicine, we're kind of figuring out what's going on and if we can treat this problem. Because as much information is out there, weather information is a commodity now. You can get it everywhere, as I mentioned before. It's almost too much. People are just bombarded with weather information. They don't know how to decipher what's real, what's accurate, what's not. And it becomes like that car alarm that always goes off and nobody listens to it anymore. So how do we solve this? Well, luckily, the Weather Service and a lot of academics are now starting to take all of this technology, the forecaster, the tools, and now social science to kind of take it out and create new products that hopefully through technology, and this is where I'm a big fan of apps if they're done correctly. I think the apps we have now aren't great, but there's a place where the apps are going to be huge. Because the social science part of this is huge. And sometimes communication is huge. So I made this graphic about a year ago, and it still circulates like crazy. Because for everybody who didn't know the difference between a watch and a warning, I'm like, here's a simple way to understand. Like, what if apps could give you information this way? Instead of giving you all the gobbledygook, simplify the communication. One of the things I tell my students is, one of the hard things we do, and TV is the number one culprit of this, we try to make things harder than it is. Everybody knows where the men's and women's bathroom is in there, right? Have you ever been to one of these restaurants or bars where they got some funky artistic thing, and you're like, oh my God, which bathroom is it? And I fear as a dad, my son's running back, and he's like, Dad, I don't know which one's the men's bathroom, because there's some weird artist rendition of what a men's or, why? Just tell people where the dang bathroom is. We try to outthink ourselves, and we do this in weather all the time. We try to create these fancy graphics, and it's not to be simple. People got to understand. One of the things that we do is we use too many dang colors. That grid is every color represents a different type of weather watch, warning, or advisory. All right? And I just pointed out the tornado. It is confusing. Like, why in the world do we have 100 different colors? And you're supposed to interpret this in like 6 minutes, right? Or for my case, 2 minutes and 30 seconds on the news. So a tornado watch is red, right? No, sometimes it's yellow. This is from the government, right? They can't even use the same colors on different websites and apps. It's crazy, and we wonder why people are confused by the weather. The Weather Channel uses red. Okay, some stations use purple. Like, I've been trying to get all the stations to work together and use the same color for a tornado warning, because I'm not egotistical enough to think everybody watches me. Depending on what's on TV, you're watching somebody else, right? Or time of day, you're not watching at all. So let's use the same color, so no matter where you see a warning, you know immediately what it is. Okay. So one of the things I've done is I've simplified the process. At my station, we've gone to the low, medium, high, extreme. Everybody on their dashboard knows when the yellow light comes on, something bad happened. They know when the orange light, it's getting worse. When it's red, it's done, right? The stoplight mentality, people all get that. So why don't we just stick with that, So for Matthews impacts, we use that color scheme. We use it in bar chart form. We stay consistent in the color scheme so that regardless of it's snow, hail, sleet, freezing rain, tornado, flood, we have these threat colors that all mean low, medium, high, and extreme. And then the follow-on information is to tell you what that threat is. So a red alert for this, or a red alert for that, or a red alert. So it simplifies the process. And the good news is, it works for all types of severe weather, even winter weather. So the Weather Service is slowly going this way. If we could get all the TV stations and all the apps and everybody to be on the same page, the communication of this information would be a lot simpler. So one of the things that is pretty cool that's coming down the road, one of the coolest things I got to do, besides seeing GOES 16 launch, I got to go to Oklahoma and be in what's called the Hazardous Weather Testbed at the Storm Prediction Center and the National Severe Storms Lab. They're working on something called facets. So the goal of facets is, this is a current tornado warning. The future is to have like a plume diagram that shows the threat increasing or decreasing for a tornado. So even if you're not in a tornado warning, for instance, if I'm right here, and I'm in a hospital that takes me an hour to move patients from the upper floor down, and I'm not in a warning yet, I want to know if my threat level is increasing or decreasing. So if I'm in a situation where I need a big heads up, like a mobile home, if someone's in a mobile home, you have to get in a car and actually drive somewhere else. 10 minutes isn't going to help you. In my house, 10 minutes is fine. I can get to my closet in 2 minutes. But if I'm in a mobile home, I have to leave. So I need to know if I can leave and there's a tornado coming in an hour. So in the future, I'm hoping that apps will take this, use this, and have a threshold where your threat is every minute you get an update. Is your threat increasing or decreasing for a tornado? I think that's important. Instead of just a binary tornado warning, not tornado warning. And if I'm in a tornado warning, am I here, here? If I'm in this part of the tornado warning, guess what? There's no tornado. So this cuts down on the false alarm rate. It gives people added information. In the future, the Weather Service is going to put out these plume diagrams that will help people plan ahead for severe weather. And that's the goal in all of this, is to create the technology that not only uses the accuracy of our forecasts, but it helps communicate and give you information that's useful. And that's my goal, is that maybe at some point in the future, there will be apps that will actually have personalized data. And we talked about this at the beginning, that that's the goal in all this, is to take this great technology and the people and merge them together to give people information they want. People, I feel like I'm always going to have a job. It may not be on TV. It might be a digital space. But the thing that I know is that people want to hear from you. The thing that's made my career so successful is not telling you it's going to be sunny and 80. It's letting you know if you can get to your kid's soccer game on time, if my golf game's going to be rained out, if the tornado is heading towards my house. So technology is offloading the easy stuff for me, and I'm able to concentrate on the hard stuff, which is like forecasting the chance of rain at a soccer field at 3:30 in the afternoon, or a tee time at 8 a.m., or in the worst case scenario, Hurricane Florence heading towards your house. Because these threats are going to increase. With climate change and with the severity of our weather getting worse and worse, I think this is going to become the biggest, the biggest job in my future is going to be helping to predict these things and communicate them to the public in a way they can understand.